Circle the odd one out. We got this little thing right here. A increases, A1 plus A2, and out of phase. So the correct answer is D, out of phase. This is because A, B, and C all represent constructive interference, whereas out of phase is a characteristic of destructive interference. To fully understand the ins and outs of wave interference, check out the video in the description. Number 2, which of these graphs correctly depicts the distribution of energy for the shells within a Bohr atom? The correct answer is B. So this equation right here maps the energy of each energy shell n, where the energy values are negative below the x-axis, energy increases as n increases, and the energy of each n shell is represented by dots due to the restricted possible values n can be, simply positive integers, 1, 2, 3, 4, etc. To make sure you understand the Bohr atom, its energy shells, and the electrons that occupy them, check out the video below. Of these 3 electrons, which one has the most energy and which one has the least energy? The correct answer is actually D. This has the highest energy and this has the least energy. So energy increases as you go farther and farther away from the nucleus. So that makes sense that this would be the highest energy. But why isn't this one? Seems like because it's closer to the nucleus than this one, that this would have lower energy. But this plays into the discrete nature of energy shells and the electrons which occupy them. No electron is going to be found in between the shells because electrons can only be exactly where the shells are, and each shell has its own discrete energy. There's a video in the description to clear up any confusion on electrons, atoms, and energy levels. Which of these terms describes the dotted line highlighted in yellow? So the correct answer is atomic radius. There are multiple dotted lines in this atom, one going over here, one going over here, one going over here, and this one is the longest because it's the separation between the nucleus and the outermost electron occupying the atom. So we could think of it as the atomic distance because it's the distance of the atom. Because the model of our atom is a circle, this is technically the radius. So atomic radius is the right answer. Number 5, what form of light is more directly described as kinetic energy? Waveform, particle form, both equally, or neither? The correct answer is the wave version of light is more directly associated with kinetic energy. The waveform of light carries energy associated with its motion through space. C is propagation or travel speed. So as waves of electromagnetic radiation propagate, they transfer energy from one location to another. Photons or light particles are more so associated with the energy changes they have the potential of inducing in the matter they interact with. So in the description is a super important video on wave particle duality, as well as light energy and how to calculate it.